Hello everyone, welcome to this video. Let's move on to the last question of this chapter, which states that 150 workers were engaged to finish a job in a certain number of days, right? So this is given to us. Now what they are saying 4 workers dropped out on second day. Let's see the condition what they are saying. They are saying initially 150 workers were employed to work for something, right? On the first day they were these many. Next day they drop 4 of them leave out and 146 are left behind on the second day, correct? Then 4 workers leave and we are left with 142 workers on the third day, and this keeps on happening like that. 4 workers each day are leaving out, right? So this is one thing that they are saying. Let's see the question. 150 workers were engaged to finish a job in certain number of days. 4 workers dropped out on second day, 4 more workers dropped out on the third day, and so on, right? It took 8 more days to finish the work. So we need to find the number of days in which the work was completed. So let's consider that initially if 150 workers were employed per day to complete without any worker leaving, right? In that case, let us suppose that the work be completed in X number of days, right? Now they are telling you that for that X, we are required 8 more days when this condition happens. When 4 workers drop out each day, right? Each corresponding day 4 workers are dropping out. In that case, we would have the total number of days in which the work would be completed would be X plus 8, correct? So because we have assumed our X to be the number of days in which 150 workers per day would be employed to finish the work, right? Each day 150 workers, if they are employed, in that case we would have our work completed in X number of days. Now we require X plus 8 number of days. So if 150 workers per day were engaged for the work, so how many total number of workers required? It would be the number of workers working each day, which is 150, and the number of days, which is X. So these many workers are required. So let's mark this as equation 1. And when to complete the work, right? And when would this be the criteria? When we have no worker leaving for us. Each day we have 150 workers working for us, right? Now according to the situation which is given to us in the question, we have 150 workers working on first day, 146 on second day, 142 on third day, and so on. So how many total days are required in order for our work to be completed? It would be initially, if 150 were required, it would be 150 days only, X days only. However, now because the workers are leaving, our work would be extended to some few more days, and those few more days are 8. So in total we have to look for X plus 8 number of days in order to complete the work, right? So therefore the total number of workers which would be required for in this case is, you see, on the first day, first day we have 150 workers. On the second day, the number of days 1 only, right? The second day we have 146 workers. Then on the third day we have 142 workers, and so on. So we have to look for the X plus 8th term here. So whatever is the sum up to this X plus 8th term, we would have that equal to the total number of days that is required here in order to complete the work. And you know, this sum would be equal to this sum because overall our work has to be completed. Here it is completed in 150x, here it is completed in, when you calculate the sum of this thing. And now what is this thing? If you notice carefully, it is an arithmetic series, right? The first term is 150, the common difference here is -4, and we have to look for the sum up to X plus 8 term, correct? So you know the formula to calculate the sum up to n terms. It is n by 2, 2a plus n minus 1 times of d, right? Here your n is X plus 8, so you can substitute it here. The value of a is 150, the value of d is -4, so you can substitute and solve here. Now this is equal to 150x, as I have told you. So you can equate both of them, right? Once you equate them, you will have an equation in x. So you can solve for the value of x. Once you know the value of x, x plus 8 would be your answer. Remember, x plus 8 and not x would be your answer, right? So you can solve for it. You can take 2 common from these terms, you can cancel them out, you will be left with this term, simplifying give you this term, right? Again, what you can do, you can take 2 common here, 2 common here, so that we can simplify our calculations, right? So you have 75x is equals to this term multiplied with this term, which is this one, correct? Then you can simplify this equation furthermore, which is a quadratic equation in x. So we would have 2 solutions for this equation, right? You can factorize the given equation. So you see plus 17 and minus 32 comes out to be its roots or solutions. So now this case is not possible. Why? Because x represents the number of days, and number of days can't be negative. So therefore in this case x is equal to 17 is the correct answer. Hence the total number of days which are required to complete the work would be 17 plus 8, which is 25 days. So in 25 days our work would be completed. So I hope you understood this question well. That is it for this video. Thank you for watching.